Hi everyone, I'm Junaid. This is my research topic, which is fatigue in traffic signposts. Moving on to introduction, as the structure becomes slender and lightweight, the traditional civil engineering aspects and views cannot be applied on this structure due to the complexity in its calculations. Advanced analytical practices should be used in order to design as well as analyze these structures. As these traffic signboards are highly affected by wind forces, there is a requirement of enormous number of complex aerodynamic calculations involved. So in this paper we focuses on fatigue on signboards. So what is fatigue? Fatigue is the damages caused in a material due to repeated application of load. Wind sensitive structures are highly affected by fatigue due to the frequent application of load during a period of time. The damages in the structure due to fatigue are progressive as well as localized in nature compared to other damages that can happen to a structure. Even if the maximum stress due to fatigue is very less than maximum tensile stress that the structure can take, the fatigue damages can even occur then, because this is because of variable periodic loading. The factors which can lead to fatigue are shape of the structure, surface quality, material type, environment, temperature, location. Wind grid size is another factor which can contribute towards fatigue. Then support condition is another factor. Frequency of high velocity wind is one of the important factor which should be considered while considering the topic fatigue. So what is the need for fatigue analysis in signboards? So since these traffic signboards are highly affected by wind forces, like when we take a drive, we can often see the wind signboards often torn out due to wind forces. In order to increase the durability of these structures, there is a need for fatigue analysis. When this load reaches certain limiting value, microscopic cracks will happen on the surface of the signboards, which will progress along with the time, which will finally lead to the damage of the structure. The characteristic of fatigue failure in traffic signboard. The main characteristic that is found in fatigue failure is discontinuities in the signboards, like holes, maybe separations. All these can contribute towards fatigue due to increasing concentrated stress in these points. Fatigue, as I said, the fatigue cracks are progressive in nature. Once a crack is formed, it will progress in all directions, ultimately lead to the failure of the structure. So even under a controlled environment, the fatigue damage is unpredictable. Usually fatigue failures are found in tension members, even though fatigue failures are also found in compression member, but it's usual in tension members. As the stress applied increases, fatigue decreases. It's common as that. Fatigue of traffic signal is influenced by shape, size, wind direction, grid size of wind, etc. As I already explained. Now moving on to the analysis. As we take a look at the first picture, if there is a hole or a notch in case there is a hole and a notch in the signboard, the stress concentration will take place around these holes and notches, leading since once the whole fatigue cracks are found on the structure, it will progress and ultimately lead to failure. The fatigue failure happens in 4 stages. First, the formation of stress concentration point, like maybe screw hole or separation between the boards, etc. Then growth of cracks, as shown in this, there is a growth of crack, then it will develop, then ultimately leading to the failure. So in my research, in order to analyze the fatigue failure, I have adopted a method known as SN curve method, which is pretty much accurate when compared to other method which exist now. In this method, the cyclic stress is plotted against the number of cycles till the point of failure. As you can see, this is an example of SN curve. Here, at the point of failure, you will attain a neutral value. This curve is plotted in a logarithmic scale. Now steps steps for calculating a fatigue in a signboard. In order to get an idea about the fatigue life, the maximum stress that could happen on a signboard as well as the minimum stress is found out. Then it is evaluated with the help of this expression, which is log n is equal to log c minus m log s. In this, the maximum and minimum stresses are all applied. The n is the number of cycle, c is a constant which depends on the material, type of material used, which may vary according to steel, aluminum, whichever the material is used. S is the amplitude of the stress applied, and m is the slope of SN curve that I explained earlier. So according to the analysis, some of the key aspects that should be considered while designing a traffic signboard are some of these. This is based on the previous studies as well as my personal experience as well. If the stress applied is lower, the fatigue life will be increased. Avoid the local stress development, such as avoid screw holes, separations in the board. So I employ more and more weld joints, use butt joints, use more and more double-sided joints rather than single-sided joints. Then periodic inspection of joint should be employed. Then the quality of joint should be ensured. Since the fatigue cracks are sensitive to wind direction, the locality where the structure is installed should be analyzed thoroughly before the installation, such as wind analysis carried out in order to get the aerodynamic data, wind direction, etc. should be analyzed thoroughly. Now moving on to conclusion of my research, the proposed procedure for the calculation of fatigue life is pretty much accurate when compared to previous studies. There is the various factors like maximum and minimum stresses, materials used, cyclic loading, etc., and various type of factors that will contribute towards fatigue are analyzed. Research design. This research is carried out in a mixed way, which include collecting data, analysis, then interpreting my own experience as well as the experience of my tutors, lecturers, and my colleagues. It will also make use of quantitative and qualitative research as well. Now the limitation that will be interpreted during the research will be the small number of reliable sources which is relevant to the research question. Availability of data, which is very scarce because it needs modern techniques like in order to analyze the wind direction, wind analysis, etc. Lack of hardwares. Interpreting this information is really tedious, and these are some of my references. Thank you for watching.